Photons are the gauge bosons, the force carriers for electromagnetism. Whenever charged particles interact, photons are exchanged. They have no mass, no electric charge, no weak charge, no color charge. The epitome of almost nothing at all, and yet here is where it's at. Since they are responsible for all electron and proton interaction, everything we do in our everyday life, from moving a mouse to running in the park, relies on the exchange of photons. They are energy contained in shifting and changing electric and magnetic fields. Like all particles with no rest mass, photons travel at the speed of light. They cannot come to rest. Photons, in the range of visible light, carry just enough energy to excite a single molecule in a photoreceptor cell of your eye. Gravitons are the as-yet undiscovered force carriers for gravity. Because of the great success of the Standard Model in describing the other three forces which exchange bosons, it is assumed that gravity has a gauge boson as well. Its properties have been extrapolated. It is a massless, stable, spin equals 2 particle that travels at the speed of light. Gravitons may not be constrained to the dimensions of space and time that we experience. Weak bosons, also called intermediate vector bosons, are the exchange particles for the weak nuclear force. There are 3 of them called W+, W-, and Z0. They are very massive, each being 80 to 90 times as heavy as a proton. Because they are so heavy, the uncertainty principle allows them only an extremely short range when they act as force carriers. So the weak nuclear force has a range about only 1/100th the diameter of a proton. The W bosons cause quarks to change flavor, while the Z has an effect in an esoteric type of interaction called neutral currents.